So hey guys, we're back. For this summary video, we will tackle the chapter 3 titled Networks and Protocols. Network protocols and communications. So with this we have four sets of chapters modules in chapter 3. So with this chapter, we are going to talk about what are the network protocols. We have what is the OSI model, what are the uh, PDU, what are the protocols used, the IP address. So we have the destinations, the receiver, and the communication. For me, before we summarize everything, communication is being used even before the Stone Age time. We have sign languages and uh, verbal speaking, verbal language. Then as time goes by, the communication is being easier and easier. As of now, we are using for the communication, excuse me, as a you can call from through phone or through internet, just like Viber or Messenger. You can call, and with the communication, it gets easier and easier. You can communicate from the all around the globe, from Philippines to say, for example, your auntie is in America, in USA, you can communicate with the snap of the finger, uh, or within 1 second, he or she can reply or can answer your call. So with this chapter, we can let's proceed in 3.1.1, the protocols used. Yeah, let's have this. Human communication, just like I told you a while ago. The internet's slight laggy. Yeah, there you go. So there it is. We have the message or the source. We have the signal. Signal is uh, probably how you speak, and the message is your message before you speak, and you transmit or on how the receiver can understand the message you are saying and the destination. If the destination or the receiver received the messages you are saying, it means the communication is correct, or it is what's that? Correct. What else? Or nothing is bothering, or no noise is blocking the communication that you are having with one another. With the communication, it's just the same. We also have the message, the transmitter, and the receiver. For example, we have the computer, two computers. You send an email or any information or to other computer. The we have the transmitter or the signal is we have the LAN cable, we have the internet, or we have different transmitter that transmit the message. And then if the receiver receives the information or the message that you want to pass or give, it means that the communication is correct, or let's say successful. And we have here message encoding to be more precise, or more info about the communication. First, let's have the human communication. We have the source, encoder, transmitter, transmission medium, the channel, receiver, decoder, and the message destination. So let's say we have two people. one, the boy and the girl. I'll let you watch first. Yeah, the girl says, example, what a beautiful. I look at the sky. It is a beautiful scenery. So if the receiver gets the message correctly, he is uh, already looking at the beautiful scenery of the sky. But if not, or the medium or the transmission is not correct, or there's a problem like noise, or the message is uh, not that clear, like abulong, kumbaga, yes, it means that the destination, the boy, is didn't get the message correctly. And computer, also the same. So from here, this part, the first computer, let's name it, the computer one, is the source of the message. So he encodes the uh, mail or message or like a picture and transmit it through a medium or channel to the receiver, so that the receiver can decode the message that the PC one or the computer one is has transmit the message. So just like that, the communication or the transmitting of message is successful. The PC1 sends and the PC2 receives the correct message. So also, what is MAC address? Let's proceed to 3.2.3. So here we have IEE, IANA, or Internet Assigned Numbers Authority. These are open standards. So this means open standards encourage interoperability. Sorry, yes, the font is too small. Competition and innovation. They also guarantee that no single company's product can monopolize the market or have an unfair advantage over its competition. A good example of this is when purchasing a wireless router for the home. There are many different choices available from a variety of vendors, all which incorporate standard protocols as IP version 4, DHCP 8, 802.3, or the Ethernet or the 80.2.11 wireless LAN. So these lay of this probably these examples are oh, like an open standards or the organizations that are deploying or selling the different various of wireless connectors, like your wireless router, your LAN, that has each standard protocols like IP version 4, DHCP for Ethernet, and wireless LAN. Here, the Internet standards. So we have the ISOC, the IAB, the IETF, and the IRTF. So with this, from the ISOC, the Internet Society, it breaks down by the use of Internet Architecture Board. And in Internet Architecture Board, we have two task force, the Internet Engineering and the Internet Research. With the Internet Engineering, they develop and updates and maintain the internet. While in Internet Research Task Force focused on long-term research related to the internet and TCP or IP protocols. So as of now, we have IP version 6 that is probably we are currently using it. I don't know with my internet right now, but with the IP version 6 protocol, they can probably faster or higher connection. Yeah. So the research task force, they they have more time on focusing on how to develop the internet, or how the internet can withstand longer and uh, can withstand the amount of consumers or the users that the users are using the internet. And the develops and the engineering task force, they develops, updates, and maintains the internet. So the three main tasks that the internet engineering are doing is developing, updating, and maintaining the internet. They develop uh, they develop the internet on how the consumers or users can use. They update if the internet is not that good. They replace it with a different or much better version, and then they maintain the proper connection that the people are using. And then in the protocols, these are the protocols that I mean, yeah, protocols. So we have the different protocols like TCP, IP, the uh, near. For more examples here, HTTP, the Hypertext Transfer Protocol. Uh, y- we are using the HTTP for the browser for purposes like here, HTTP. That means the protocol, or this is the protocol for CCNA 1, or the proper protocol for the specific website. And for the TCP, the Transmit Control Protocol, and the Internet Protocol. So they always come in pair, TCP and IP. So with this, as you can see, another figure, let us all agree that if one of our pathways is down, we will notify all connected devices. So these are the routers. So from router 1 to router 6, router 5, if the connection of router 1 is down, they will notify every routers or connected devices that the system or the router is down. So that's the protocol. It's the role of the protocol. And let's excuse me. Let's all agree that error messages will have a unique ID number. So with this, the path A is down, so that the error message has its unique ID number. For example, the router number 1 is down, or error 1001 path A is down, error 10002 path B is low, because with different or unique ID number, they can distinguish, or they can easily locate which path or router is down. Last figure, I agree we can now send and receive information between us. I would like to set up a virtual connection with you so we can exchange information. As you can see, the the connection or the path is clear and nothing is down. So that is the setting up and transmission termination of data transfer sessions. So if the connection is not down or the path is not down, nothing's wrong, or there's no problem, the termination and setting up of data transfer is ongoing and nothing is bothering with the user. And lastly, what is MAC address? So network addresses. So we have the physical, data link, network transport, and upper layers. With the network addresses, like they also have the unique addresses for each uh, source and destination. I mean, they have the unique IP address or address for each connection. For example, the connection A is going to transmit the message to connection B. So the connection A address is 192.1.680. So the transmission, the destination, I mean the source is from connection A going to destination 192.1.608. That is the destination IP address. The source and destination IP address is the same because if they are not the same, the destination is not correct, or they can't the message won't be received by the client. So yeah, for me that's the whole summary of chapter 3, the network protocols and communication. To be more uh, precise, the communication, if the system is down, there is always an other path that the message can be transmitted to other computers. But if everything is down, it means that no uh, or nothing can be, or everything is down, the system is down, internet is down, the connection will be lost. So that's the the challenge of you can't send or you can't pass the message to other computers. So yes, that's it guys for chapter 3, network protocols and communication summary. Thank you.